Hello to all of you. You are watching this video. From this lesson until lesson 15, we talk about constraining tools. So far, you learned how to draw different shapes, correct and complete these shapes. Now you learn how to constrain them. In this lesson, you also learn about colors and their meanings. Okay, let's go on the screen and start the lessons.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With Katia, I cut through strife. In my mind, the future's clear. No more doubts, no more fear. Crafting visions in 3D. Katia's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. Katia helps me innovate. Every line precise and true. Colors bright and brand.
Hello everyone. Well, today I want to talk about constraining. I'm currently on the Sketcher page. You should also enter this page. The constraint toolbar includes 5 categories of tools. Before checking the tools in this toolbar, you must learn a few important things. The first thing is the color of the drawn elements. The white color is commonly called the rough color. When we draw an element, it is initially white. I have drawn a triangle now. The triangle is a right angle triangle. If you open geometry, you will see 3 lines and 3 points in it. They are the building elements of the triangle. The color of all of them is white. If I click on one of them, so that element goes into selected mode, its color becomes orange. So the orange color is for the selected element or command. Generally, anything that is selected is shown in orange. We also have 4 other colors for drawn geometric shapes: green, purple, red, and brown. Each of these colors indicates a state of the drawn element. If all elements of the drawn shape are fully constrained, their color is shown in green. This state is ideal for us. Note: you can take a drawn geometry to the part environment without fully constraining it and make it 3D. Note: always fully constrain the drawn geometry before transferring it. Now I have shown another triangle on the page. Its color is green. You can see that its dimensions are complete. Even its distance from coordinate axis is given. Here you must pay attention to the 2 points. If you remember, I said before that when drawing shapes, do not draw them precisely. At that time, I said that During constraining, we would make them precise. If you pay attention to the numbers of the triangle's dimensions, you will see that all of them are written with 3 decimal places. These 3 digits are the software's precision limit. The numbers are in the millimeters. Note that we can change the precision limit. I will explain how to change the software's precision limit later. Now we want to change the length of the triangle size. It is enough to double-click on the dimension number. The constraint definition window opens. In the box opposite value, the dimension value is written. On the drawing page, the dimension has also turned orange. In this box, we write our desired number. For example, I write number 35. I press the OK key. This dimension is still in the selected state. It is observed that the side of the triangle changed and its dimension became 35 millimeters. Click outside on the drawing page. Now I will change the dimension of the second side. I double-click on the dimension. Again, the constraint definition window opens. Inside the box, I write the number 30.5. For the decimal point, use the key on the keyboard that shows a dot. Click on OK. Click outside the dimension. It is seen that the dimension 30.5 was applied to the side. Now I double-click on the distance of the horizontal side from the horizontal axis of the XY plane. I write the number 30. Right-click in the box. From the Open menu, select the Add Tolerance command. The tolerance window opens. There are 2 boxes in this window. The lower box, Minimum Tolerance, shows the minimum deviation from the base number. The upper box, Maximum Tolerance, shows the maximum deviation from the base number. Double-click on the upper box until it turns blue. Type the number 0.05 in it. Double-click in the lower box until it turns blue. Write the number 0.02 in it. Click on OK. Click in the main box. Click on the page and outside the dimension. It is observed that the number 30 was shown with 2 tolerances, plus 0.05 and plus 0.02. If we want the minimum tolerance to be negative, in the tolerance box in the lower part, we should have typed a minus sign before the number. Now double-click on the remaining dimension. Change the number opposite value to 40. Right-click in this box. From the Open menu, select Add Tolerance. In the upper box, type the number 0.05. Press the Tab key on the keyboard. Type the number minus 0.05. Click on OK. In the main window, click on Again. Click outside the dimension. It is observed that the number 40 is displayed with an upper tolerance of plus 0.05 and a lower tolerance of minus 0.05. You notice that the upper tolerance box was blue. You notice that we press the tab key to go to the lower box. On the page, you see two types of dimensions on the triangle. The first type of dimensions that specify the dimensions of the triangle. These types of dimensions are known as internal dimensions. The other type of dimensions that show the position of the drawn geometry. This position can be relative to the coordinate axis of the drawing page, or it can be relative to another constraint shape. Suppose we want to constrain the first triangle. First, we give its internal dimensions. These were the dimensions related to the shape itself. Now we specify the position of the triangle relative to one of the sides of the other triangle. It is seen that the first triangle also turned green. So, note that the position of the shape can be constrained relative to axis or another shape. Note, pay attention that if we constrain a geometry relative to the coordinate axis, given that the axes are fixed on the page, the object will no longer be movable. But if we constrain a geometry relative to another geometry, with the movement of the first geometry, the second geometry also moves. Now I will delete one of the triangle. Suppose we imagine that the hypotenuse of the triangle has no dimension, and we want to dimension it. It is seen that by dimensioning this hypotenuse, the color of the triangle turned purple. The purple color means over-dimensioning, or in other words, over-constraining. To return the shape to the green state, we must delete one of the extra dimensions. Here I have given an extra dimension on the internal dimension of the triangle. I don't necessarily have to delete exactly this dimension. I will delete one of the other dimensions related to the triangle's side. I click on one of them until it turns orange. I press the delete key on the keyboard. It is seen that the triangle turns green again. Now I give the distance of one of the sides from the axis again. It is seen that the part of the triangle turned purple. I click on that the same dimension until it turns orange. I press the delete key to clear the dimension. Now I give the distance of the hypotenuse from one of the coordinate axes. It is observed that the entire shape turned purple. It is observed that there are no extra dimensions. Open the constraint subgroup in the design tree. The last dimension is offset 0.46. I right-click on it. Its properties window opens. In the color section, you see the purple color. Click on OK to close the window. While offset 0.46 is active, press the delete key. It is seen that the offset is deleted and the triangle's color turned green. Press the key combination Ctrl+Z. You go back one step. Click on offset 0.29 to select it. Right-click offset 0.29 to open its properties window. It is seen that in the color section, its color is also purple. Suppose we have a right angle triangle on the page. You know that in a right angle triangle, the length of the hypotenuse is equal to the square root of the sum of the squares of the other two sides. Now we dimension the two sides. By having the dimension of the two sides of the right angle, the hypotenuse dimension is known. We dimension the hypotenuse. It is observed that the color of the triangle turned purple. The software tells us that over-dimensioning has occurred. I delete the hypotenuse dimension and correct the side dimensions. I give the two sides of the right angle 25. The hypotenuse dimension, according to the given dimensions, should be 45.355. I dimension the hypotenuse. Now I change the hypotenuse dimension to 50. I double-click on the hypotenuse dimension. I type the number 50 and click on OK. It is observed that the hypotenuse turned red. The red color means that a hypotenuse of 50 is not possible. So, if you enter a dimension that is not possible, the corresponding element will turn red. I delete the dimension 50. The last color is brown. I will explain this color later. For now, the lesson is finished here. Watch the lesson twice. Practice with me the second time. Good luck. Goodbye until the next lesson.
Let's build the future. Come with me, don't hold back. Turn your thoughts into a track. Dream it, see